Hello, everybody. Welcome to this session about building apps for a changing world using AI. You've probably seen a lot of the announcements at Build and from the platform work at Microsoft with all the power that AI can bring to building your applications. I believe we're just scratching the surface, and Amit will, in this session, talk about one of the more exciting and more areas with the most potential. Amit Bari is part of the AI platform team. He has been working with us in the Decision AI team, helping build some of the features we're going to talk about today. And he brings an amazing experience of both building products and deploying them in the field. Before we start, we want to tell people, please put your questions in the Q&A. We'll be addressing them towards the end, and we'll be reading what you write. So we will probably combine or analyze which questions to prioritize to make it all make sense. With that, I'll hand it over to Amit, and thank you.
Thank you, Ed. Thank you all. I appreciate you taking out the time to come listen to us. I do want to give a big shout out to Ed and Jeff, my partners in crime. They're the ones who do the hard work so I can look good. Hopefully I'm looking good. I hope everyone's safe. I don't know anyone who's not been impacted by the pandemic and the craziness going around us in some fashion or the other. I sometimes feel I'm the lucky ones. The only thing I really have had to worry about is this mop on my head, which my wife keeps threatening to clean up, and I'm too chicken to let her do that. Maybe after Build is done, I'll have enough courage to be able to do that. But the forces that we are seeing today and creating the chaos, are deeply uprooting the habits we have and the patterns and the behaviors, both as individuals, as companies, as businesses, organizations. And what's becoming clear and fundamental is our sort of seemingly weird behavior is messing up a lot of the AI models. The machine learning models that have been trained on sort of normal behavior are starting to show cracks. And we as humans have to step in to sort of straighten them up. And one thing we're seeing more and more is organizations who can adapt themselves quicker and faster to sort of this changing world will come out stronger as we progress in this. So I wanted to cover a few areas in that area, but to start with, just briefly on cognitive services. So there's, as some of you might be aware, we have 5 categories of these services. There's perception-based ones around vision, speech, and language. And then decision services that help you make an informed and efficient decision. And then finally, search ones, which surface information across a wide variety of sources. And the benefit of the cognitive services are, that you use these AI services, which are ML and RL powered, to build your real world and proven use cases and solutions. They are inherent in it being responsible and trustworthy. And more importantly, right, you don't need any AI expertise to be able to tap into the awesome power that they have. You don't need to be a data scientist. Any developer can use it. For the most part, they're simple APIs that allow you to use it. So when building apps, most of AI that is used today, generally speaking, falls under the buckets of perception prediction, right? And as we sort of expand on that and start thinking about decisions, a lot of those needs to be what actions should organizations take or apps take, and in making a choice in those decisions, what's the right choice when? And the 2 set of things in that help you do that is what we're outlining here is anomaly detector and personalizer. So anomaly detector is based on time series. It's the first set of use cases. And it basically allows you to dig deeper into historical causality. And we'll cover these in a few minutes. And then personalizer allows you to adapt to unseen things. You can basically personalize an action from collective behavior of users and how things are changing. If you look at traditional 3-tier architecture, right? So, or an N-tier architecture, a lot of this is built, where AI is built is very pointy, right? It's very narrow. It's specific to this, going back to perception and prediction. But as you expand to sort of, in the decision aspect of it, you need to transition and bring on this notion of reasoning and planning as you expand into that. And in these, one has to fundamentally think if you that sort of that middle tier, which often is where a lot of logic is running. You need to start thinking of that sort of a AI living, breathing engine, right? Where you have a lot of the ML supervised learning elements, and then complementing that with some newer things that the likes of personalizer and anomaly detector allow you to do it. And we're seeing the effects of this where apps and enterprises and organizations are not being able to adapt. The algorithms behind the scene are getting into hiccups, whether it's inventory management, fraud detection, marketing, and what have you, right? So if you take a real example, right? If you make it real. So let's say if I'm an insurance company, and I want to do a car claim. Now, maybe I might get a letter or a piece of, or a text or something. I need to extract some data from that, right? So be it OCR, and this word like COVID, most ML models will not understand because they wouldn't have seen that. It's new, they won't know what to do with it. But the rules will be different now, right? Would you want that every claim you get through go to an underwriter or an agent? Or are there things you can change and adapt to say, look, a bunch of these I can do on my own automatically and improve them based on the situation, the location, maybe the vehicle it is, the damage. I can take photos, get into perception, and understand based on my data I have, combining the knowledge on actually how much damage would there be and the layers of damage, right? Because on the surface, it may not show all of it. So it doesn't mean that everything has to be manually done or a human has to go out. A lot of these new rules, new decisions, I can decide on the fly and adapt given things are quite different right now, right? So the use cases, the timelines, how it needs to close, in this case, how long can it be open or not, can be quite different and adapting to that world. So how can we use the two examples we had, right? So Personalizer, it's the world's first reinforcement learning-based enterprise service. And really, its ability to adapt to unseen things is really what's critical with this, right? And that's where some of the reinforcement learning allows us to help. And as the environment is changing around us, that's really where it can learn from and start adapting and changing. But what is it, right? So at a very simple level, it's an AI service that your application allows you to choose the best option from a set of options that you use to make a decision. And given experience, it improves over time. So as things shift, as new things come along it has never seen before, it's learning from that collective real-time behavior of content, context, and it's improving that. It's powered by RL, and a key, couple of examples where we're using it, and you'll see some on the slide. You see some examples how you can use it, but to make it real, like for example, Xbox, where Microsoft uses this, the Xbox homepage. Every time you open up, fire up the console, and you get to the Xbox homepage, the contents of that homepage are powered by this service, right? So what should they show? To Ed versus Amit versus Jeff would vary depending on our context and behavior, what we're trying to do, plus new things as it's learning from that. Each time you log into Windows Spotlight, that is powered by this. The start menu in Windows is powered by this. Our RL platform is also used in Teams as this call was started, and also to optimize hardware usage on Azure. So that's just some examples on how wide and variety this can be. And how do you use it, right? So how can two simple API calls help you learn and discover new business rules, right? So let's make an example. Let's go through one. Let's say if I am, given the situation we're in, let's say I want to build breaking news sort of section on, on MSN, or pick your news website. So I have a user who interacts with my app. There's some context about that user I have and the environment I have. I want to be clear, this may not be personalized information, right? It's not specifics on exactly who the user is. And then I have a list of actions. So in my context of the news site, I have a number of articles I want to show. And these articles could be changing quite frequently. If it is the breaking news section, it could be minutes in cases. And this is really where what I do is call this one API called rank, and I say, look, here's some context about a user, the environment they are in. Remember, the environment can keep changing on a day-to-day basis. Things we're seeing today was very, very different from 2 weeks ago, for example. And then it said, please rank in this context, please rank these actions. And what it comes back is which one article in this case, or which one action should it show? It'll go off, run the model comes back saying, try this. So in our case, we have ABC. It say, try action B, right? Or choice B to display in this case. We show that to the user, and then there's this notion of a reward, which is the second API you see. We need to understand how good was that action. So if you think about how is your app reacting or changing, this is really where your business logic, you would work on it and then come back saying, I give it as notion of a reward score between 0 and a 1. And it's a scalar, it's not a binary. And how you would define this would depend on your business logic, but you get a reward back, and these tie to your business outcomes and KPIs. And then once we get the reward back, the RL model learns from that, it updates itself, and next time you call rank, there's a newer model, right? So this collective behavior, sort of, if you go through this whole one cycle, as you go through this whole cycle, as more and more users go and more data goes through it, the model's learning and understanding from that. And then inherent in this is it'll always keep, either it'll say, look, I'm going to send you the best action as I've learned, as you're giving me that reward saying, yes, that's good. Or now and then I'm going to go try something new. And that's really where it starts getting into these unknowns and adapting to new things and new context and new environments that it is seeing as it comes through. But how do you, in terms of code, we've always maintained it's a simple two-set of APIs. So before we switch to Visual Studio, just to show you briefly. So let's say I'm going to build a simple web app, which is about food. I love food. Probably eating too much these days, stuck at home. But if I want to say, look, I'm going to have some context about a user, maybe the time of the day, some taste features which I may or may not know about the user, but I may have these attributes and context information about items of food. And then I can call this API, and I have actions, right? These are my list of actions. I have attributes against these actions, and then there's sort of a unique ID. I need that unique ID because at some point when I call back a rank, a reward after a rank, I need to correlate them back. And then, so that's my list of actions. And then I call, it's as simple as calling the rank API saying, here's the actions, here's the context, here's the event. Please go ahead and rank these. And then once at some point later, you come back and give it a reward. This delay of time of a reward is important. It doesn't have to be immediate. It could be minutes long, hours long, days long as well, right? Because some business logic could run for a very long time. When you have things like complex, for example, optimization techniques or supply chain and so on, right? So there's a lot of things you will not know immediately, but at some delayed time. Let's actually switch over and show you. I'm going to do one thing. I'm going to kick off a script so we can get some traffic going, and you can see how that happens when I switch to Visual Studio. And I have it running here already, just in the interest of time. We are keen to actually get some more time later so we can get into more questions, right? So I have a simple Knockout.js web app. Actually, I'm going to show you the web app first before we switch to the code, right? So it's a simple web app. You can actually pull this down from our docs and play with it. I have some environment context information about me as a user. So in this case, it's things like where am I running, what OS I have. If this is an app running, you may know location information, weather information, and all of these could be pertinent to what you need. And I'm going to say, create one of these rank requests for me. I get an event ID like you talked about. I'm going to send that off. And then it'll come back with saying pasta in this case. And then I can give it a reward saying, do I like it or not? I've had pasta just last night, so I'm going to give it a lower reward. And then I'm going to send that back, a reward back, right? So now that we've seen it a little bit, if I go back here in the code, you can see as simple as, here's the features I have that define a user's taste. And I may or may not get these from the users. This may come also from things like location and understanding where I am. I have some things like, in our example, things like time. So I may prefer things differently on a Monday morning than perhaps on a Wednesday afternoon, kind of a thing, right? And then if we just go down, here's my list of actions that we saw earlier, right? So there's attributes associated with this. Nutritional levels and so on. And these could define into the rules I'm going to do or not do. But that's my list of actions that, again, a lot of these could be business decisions you need to take. In our case, it's simple food we're looking at. And then here, I'm going to go ahead and combine these together and send my rank request, right? Just as we saw, it's simple. Here's my actions. Here's the context I have. Thank you very much. And then at some point later, it's going to come back and say, here's what I think you should do, and then I'm going to down the road go and give it a reward. With that, I'm going to also switch over and just show you how some of this would look like. So I kicked off the just to get some traffic to show you. When you log into Azure, into the portal, you can actually see how some of this is. You can see how much data you're coming through or not. So, I just started this. As you can see, we're starting to get about 100 requests. Each of this would be that full sort of loop, if you will, right? A rank and a reward. And the other interesting aspect of this is I can come back here and start seeing how good or bad is my my model doing. And you remember we touched on that this learns by reinforcement learning. And one aspect of that, the one where we can adapt quicker to this ever-changing world and how your apps can adapt quicker is, if you think about most ML models, I get, as models, well, models don't drift, it's data that starts drifting. We have to go back and sort of clean up the data, rerun the model, train it, deploy it in production. And that whole cycle can take weeks and months. In most enterprises, for example, that's quite normal. But in our case, we could actually have a new model updated in minutes. Now, in our simple example, you're seeing here, we are updating it every 10 minutes. And this is really one of the advantages of that we have is how quickly you can adapt to this changing world as things are changing and reacting to that. So the one thing we're quite proud, we announced this yesterday, is this notion of apprentice mode. And a reinforcement learning model, one of the facets it has is that I don't train it like a machine learning model. I can only sort of deploy it in production, and that's where it starts learning. And what that means is any new model you deploy takes time to learn before it sort of gets to some reasonable baseline, which for many of our customers is absolutely okay. But then equally, there's a few for which that unknown before from when a time model is deployed to sort of it gets trained up to some level, some baseline, that delta may not be acceptable because there's a lot of decisions going through that. And that may dip down their outcomes, what they're after, and that may not be acceptable. So in that, what we have this new thing we launched yesterday. We call it a learning behavior called apprentice mode. And just like how an apprentice learns from the master, your new model is learning from your existing logic and behavior of your application. The beauty of this that we see is you do this without changing any code in your app. And then you can see how the model is gaining confidence, helps you mitigate those cold starts. And then as you're changing, this is not necessarily just brand new things, but as you're changing your use cases and actions and features, you can also go understand how that's happening, right? So you sort of skip the learning curve, and once it reaches a certain attainment of performance, once you're comfortable with it, then you can switch it out of what we call the behavior out of apprentice mode to sort of being current and online, where it is actually making the business decisions for you, as opposed to just sort of sitting in the passenger seat observing. And it helps you mitigate those cold starts. You don't have to change any line of code. And then the other thing we want to get to is how do you gain trust when you're using, whether it's apprentice mode or any of the cognitive services, right? We need to be able to empower you things that when your apps will use to earn the trust of a user. Now, these are not necessarily only embedded in things like our design document, our implementation, and so on, but it's also ingrained in the whole process. For example, we have a whole team and a dedicated process looking at responsible AI. There's a number of sessions on that if you've not had a chance to see at Build. There's this notion of harms, and there's an assessment of harms, which you think about as a threat model for society. So that's ingrained into this, right? So, and as you're building these apps, the guides you have for your customers and your users is things like, how should you be wary of data biases? What are the common risks and mistakes when implementing these in your apps? How could you mitigate some of that or not? So it's the way we like to think is it's built it in, not bolted on. And in the interest of time, I'm going to switch quickly to anomaly detector, which was sort of the second set of ones we talked about. And as I touched on, the ability or what anomaly detector allows us to do is the ability to dig deeper from historical causality. It helps you see problems and behaviors that you haven't seen. Anybody who's done time series knows it's quite difficult and hard. And then really what the beauty of this is, or we think, that it detects those unusual patterns, what are starting to happen, and then automatically selects the best model in the context of your scenario. So if you see two simple examples we have here, on the left on example one, that's more of KPIs from a revenue business outcome perspective. And the one on the right is more of sensory output, let's say from a machine on a factory floor. Now, the algorithms for both and the notion of that things are starting to go off for both will be very, very different. And what anomaly detector allows you to do is choose the right algorithm from the ensemble of algorithms on its own and pick the right one in the right scenario. And it's quite simple. It's 3 APIs you call. They are hosted on Azure. So if you prefer a PaaS architecture, it's there. If you want to run it on-prem or an edge scenario, they support containers, as do many other services we have. So in closing, the forces, I want to go back, touch on something we opened with. The forces that we're seeing now in creating chaos completely upended everything we do, right? Our habits, our behaviors, what we think is important. And organizations that are able to adapt are the ones who are going to come over stronger. So what could you do? I mean, go try out. You see, go if you haven't had a chance to play with the cognitive services, go play with them. You can go see Personalizer. You can go see Anomaly Detector. We'd also have we have a community of practice. So if you're quite interested in how is decision AI helping, where is it heading, and reinforcement learning being one aspect of that, please do come and join our community. We collectively are learning from this. We would love to hear what you're thinking, what your challenges are, what could we do for you. It's a new area right now, and how we can collectively go on that together. So with that, I think we want to open it up for questions. If you have Ed, Jeff, I don't know if there's any questions. Ed, you're on mute. I think.
Of course I am. It is the.
No, you're back on mute.
Now we should be okay. Sorry, Amit, and sorry, folks. So we got great questions from the audience here. One of the ones that you might touch upon is people are asking if the models are continuously updating versus having discrete moments of train and use. Could you touch on that a little bit and how Personalizer does RL in this sense?
Oh, that's a great question. Actually, I'm going to go back and show you. So if you switch back to my machine, I'm going to go back and show you this. So one of the things is as you're sending in your reward signals, the model is continuous learning and always updating, learning from that. It doesn't mean that a new model is automatically deployed for inference to pick up, and that's where you control it. So if you can see my settings right now, so one of the configuration settings I have is how often should I update the model in production. Even though the model may be learning and training all the time, I may choose to, it's not that every instance of that I want to deploy it. I may, depending on my business logic, I may choose how much time I want to go deploy it. 1 minute is not something I would recommend. That is just for the demo that you see on there. But it's up to your logic how you want to do that.
Great. Other questions, and I like these. People are thinking this through. So somebody noticed that the pasta was a recommended dish in the demo, but you gave it a lower reward. And they're asking, which part of the context will it associate with this lower reward? Can you talk a little bit about maybe how the actions and the context both play a role in learning the model for the future?
Yes, absolutely. I wonder if in code we would show it or just talk through. So remember, we're learning from collective behavior. It's not an individual specific behavior. And in the notion of collective behavior, we would know things like which context is weighing on which action stronger. So for example, in my case, I gave it a lower reward because I just had pasta and I didn't want to have pasta again. So I chose to give it a lower reward. Now, in my example, the context, it doesn't know I had pasta for dinner last night, for example, but it may have other information that come in. So they tie in the features you have, tie in with the actions that that you're attributing it towards, but it's not a one-to-one tie-in. So as my features are drifting, and I give it a lower reward. So like in a business case, that's where some of the models are going to go start exploring. And then I know which weights are carrying over or not. I don't know if I explained that properly.
Mm-hmm. No, I think it came through. And like, I guess the person asked, how does it learn you had pasta last night? Maybe if this was a movie site, you could have a feature in your context which says this user watched this movie yesterday, or the last watched sort of feature. And maybe a lot of people who see, like, I don't know, Star Wars 3, then go on to see Star Wars 4, depending on what sequence of Star Wars you prefer.
Right. That's a better way to put it. Thank you.
Where does the reward come from? Like you showed a button, but you talk about business logic.
Right. So even though the reward is a simple number, it's a scalar, it really is something you have to decide in your business outcomes in your app what it is. Many cases we're seeing is it's not usually a one thing on thumbs up or thumbs down. It's often a combination of various enterprise systems if it's an enterprise company, and depending on your outcome you're after. So if you go back to just picking on the example Ed had, so if you're building something like Netflix or something like a movie thing, what you would get on the reward is like our news one, actually. If I just go back to that, what we built was, did I click on the news article suggested? Maybe that's a lower reward, let's say 0.2. Did I start interacting with it more, scrolling? Did I read it all the way to the end or not? So in my example, I chose reading it all the way to the end as sort of good, right? So that got the highest reward. So you have to then put it in the context of what your business outcome is, what you're after, and then choosing based on that what your logic and KPI should be to give it a reward. The other thing I want to add on is, in many business flows, if you're thinking about taking a decision, it's not you would call this once. At different stages, you may call multiple times personalizer for different decisions that you're taking as you're walking through that. So it's not one and done. You may have multiple ones, and how you construct for each one could be a little different.
Hey, Amit, we have a final question here. I think it also points to how the systems are built to learn. They're asking about what is the criteria or metrics to determine which anomaly algorithm is appropriate for each given data?
Ooh, that's a good question. I think, so if I understood that correctly, and if not, please, you see our Twitter handles and you see the community, please come join there and ask if I didn't understand this properly. If I understood it properly, you're saying, look, if my deviations or if my anomaly or what possibly anomalies of a certain category, how does it know which algorithm to pick from? I think that's how I would interpret it. I don't know if I'm interpreting it properly or not. But what internally, again, it does is, in fact, I don't think we'll have time, but if I go back, just real quick.
We won't have much time to show you things, but we'll post maybe some links in the chat.
From the ensemble, it figures out which way it's drifting and how, and then which is the right one to pick from, basically.
Yeah. So thank you very much, everybody. please look at the screen. Here's other content to take a look at. There's great sessions on reinforcement learning for gaming, autonomous systems, and so on. And yeah, please join our community of practice. You saw that QR code. That's a chat room where we build the future of these technologies together. And thank you, Amit.
Thank you.